In the previous video, we covered polymorphism, which occurs when an object of one type can take the form of an object of another type. Specifically, we looked at polymorphism through inheritance. In this video, we will cover polymorphism through interfaces. To quickly review, an interface is described as a group of related methods with empty bodies. And once again, they are a way for programmers to agree to a contract. With that in mind, let's go back to the example we used when looking at an example of interfaces. In this example, there are two interfaces. The first is feed, which contains two abstract methods, eat and drink. The second is rest, which contains only one abstract method called rest. We then have a class called bird, which implements both the feed and rest interfaces. And since this class implements both interfaces, all abstract methods contained within both interfaces are defined within the class. We also have a dog class that also implements both the feed and rest interfaces and therefore also defines all abstract methods contained in both the interfaces. Lastly, we have a class called animal farm that contains a main method in which we can utilize the dog and bird classes as well as the feed and rest interfaces. To exhibit polymorphism through interfaces, let's go ahead and first declare an interface variable of the type feed. We will name it object1. Now, if you watched the last video, you know that Webster's defines polymorphism as the quality or state of existing in or assuming different forms. So, let's change the form of this feed interface variable to prove polymorphism is possible through interfaces. To do that, we'll type object1 equals new dog, which morphs the feed interface variable, object1, into a dog object. We can prove that object1 is a dog object by utilizing a method from the dog class. We can see that when we utilize the drink method, dog is drinking is printed to the console. Next, we will morph object1 into a bird object by typing object1 equals new bird. And now when we run the program, bird is drinking is printed to the console. Now let's create a new class that we will call cat. This class will implement the REST interface. And since it implements from the REST interface, we will of course have to define all abstract methods contained within the REST interface, which in this case there is only one method that needs to be defined, the REST method. Now let's attempt to morph object1 into a cat object. Notice we get an error. The reason we get that error is because the cat class does not implement the feed interface. The initial interface object1 was assigned. If we go into the cat class and implement the feed interface as well, then define the abstract methods contained within the feed interface, this error will go away. This tells us that an interface variable can only morph into objects of classes that implement that interface, which means the interface variable object1 can morph into a dog, cat, or bird object. However, a minute ago, it was unable to morph into a cat object because the cat class did not implement the feed interface. The last thing to point out is that object1 can only invoke methods that are defined in the feed interface, meaning if we create a method in the cat class called IAM that simply prints I am a cat to the console, then try to invoke that method through the object1 variable, we will get an error that reads, the method IAM is undefined for the type feed. That is because at this point in the program, even though the interface variable object1 was morphed into a cat object, the compiler can only see that this variable is of the feed interface, and the method IAM is not contained within the feed interface. Now, if you are new to computer programming, you may understand the concept of polymorphism, but may find it hard to think of an instance in which you may need to utilize it. Or you might already be thinking in ways in which it can make your code more elegant. But if you can't seem to think of any instances now, just know that if you consistently continue to program, you most certainly will eventually utilize polymorphism to create more elegant code. At this point, just store the concept in your memory and always keep it in mind while writing code, as it may be an elegant solution for a challenging piece of code you will write one day.